Hey there and welcome. I'm really glad to see you here. I'm Daria, 3D artist, and today I'm going to show you how to build this animation in Houdini. We'll go step by step, keeping it clear and approachable so you can see how everything comes together. Grab a tea, get comfortable, and let's create something beautiful.
Let's start with creating geometry node as usual, and let's call it, for example, a setup. Let's dive in, and I obviously need a grid for that. Let's also, I think, switch from perspective view to the top view so I can see it a bit better. I don't want to adjust grids manually, so I copy row parameter and put it in size z parameter. Subtract 1 and then multiply it by cell size. For example, I think I will use 0.5. Um, I copy this expression and just change it a bit in size x. So instead of rows, I write columns. Right now I have adjustable grid. I need to create a primitive wrangle, so I want to create ID for each column and row. Let's call it line ID prim. So here I need vector. Let's call it bbox. Real bbox at p. Mm, then we need index for each vertical line. Int bbox multiplied by, let's create a new channel, I count x. Let's click, and for example, if I change count x to 5, and now I need to visualize it, this parameter. Oh, it's color. Okay, let's change it to marker. So we can see in the viewport that all vertical lines are numbered, and now it's from 0 to 4 because I used count 5. So let's grab rows value, no, columns value, and put it inside of count x. So all the columns are numbered again, 0, 1, 2, 3, 4, 5, 7. So we have a problem here. And we need to change a bit this count x, so -1. And right now we have right order, so from 0 to 11. Great. Let's do the same for horizontal lines. Change it to H and bbox to Z and count to Z. So let's click and let's grab again rows, copy parameter, paste it here and -1. Great. So I want to see preview of horizontal indexes also. Visualize, change it to marker, and let's use, instead of blue, orange color. So now I can see all my numbers for rows and columns. They are all numerated. Looks right, nothing is missing. And yeah, great. I need to test it. Yeah, works well. Okay. Now I need color for animation, so I can use attribute noise, for example. Let's set it up. I need only red color, and let's remap it a bit so we would see more contrast here. So, and let's disable it. Now they're all based on points, and I want them be on primitives. And change some parameters here. Element size, maybe. I want red color affects only columns, so maybe it would be better to have vertical lines here for differentiation. So let's change it a bit. Okay, let's check animation and put it on 3. And I think I will reduce roughness. Hit play. I think it's good. So copy this node and do the same thing for the green color. X, so green, Y. Let's change the size a bit so it would not be X but Z size. Yeah, and we can offset it a bit. I want to use these colors for animating size, so let's create two new attributes. Again, primitive wrangle. Let's connect it and right here at amp x equals cdr. So copy to the same but create amp z and using green color. Let's rename it to amp values. Okay, great. Now I want to go through each line and store maximum amplitude value for each row. Like for example, maximum green color. Let's create a named for loop. Change the name parameter to line h attribute because we don't have name, but we have these lines IDs that we created. So here in single pass, I can see that I go through each horizontal line, through each row. That works good. As I already said, I want to store this maximum value for each row. So for that, I need to create attribute promote. Let's do that and attribute promote and change the class to primitive amp z, and I need to promote it to detail. Let's rename it so it would be amp line h and promotion method maximum. So now I need another promote attribute, but right now we will promote it back to primitives from detail. Let's also create attribute remap so we wouldn't have zero values. I think I will set up a minimum as 0.2, no, 0.1 would be nice. So, and now we do the same logic for columns now. Let's create for each loop. And let's change the name attribute again to line V. Single pass, and we go through each of them, each of the column. So now I want to store maximum of a red color, red amplitude here for each line. So attribute promote, change the class to from primitive to detail. Now amp x, maximum, change the name. Let's change it again to amp line v because it's vertical line. Let's create another attribute promote. So detail, primitive. Okay, great. And let's copy attribute remap. Change it only to v. That's it. Now let's fuse it. And because I used for loops, now all my primitives are separated, as you can see, and I want them back together. So I use fuse node to merge all these points. And now I need again attribute promote to save my maximum line amplitudes to points. So amplitude line H and copy, and now amp line V. So we promote it to points. And let's create a bound node. I need it for later, so Let's keep original. We don't need to create the bounding box. And let's check radius attribute. So I need it for later, and we can see in detail attributes that we have right now, radius attribute. Maybe I will add some attribute delete to delete IDs for my lines. So let's check them. Oh no. Primitive attributes, line H and line V. We delete them because I need to do the same but for points, not for primitives. So let's copy our line ID node that we created. But let's run it over points. Let's visualize it. Now we can see these attributes. In the viewport, we can see everything, all these IDs, but for points instead of primitives. Let's try to change something. Yeah, that works fine. Nothing is broken. And next thing should be sorting points. Let's apply sort mode and let's sort it by X. Another attribute wrangle, and let's write something here. I want to have a sum of all previous points amplitudes and store it in a new attribute. So let's write at position z equals 0, and right now we need to create for loop for int I equals 0, I less than line h, and then I plus plus. So we created this for loop. Let's create float value and equals point from our first 0 input, attribute amp line h, and based on the I number. Okay. So now let's store it into position. Pos z plus equals value. Let's rename it to something like store position z, and let's copy these two nodes, and we do the same but for position x. So let's sort it differently. Change everything to x, v, v, x. So let's change the name to x. Let's visualize these attributes that we created. Turn on pos x, visualize, we don't need those, and we click edit, marker. We change it to red because it's x, position x, so it's red. Now, as you can see, each value increases every time, and it adds previous amplitude value to itself. Like we have the range from 0 to 7. So now we will do the same for position Z. Let's check it, change it to marker, and let's select green color. Great. So you can see again that it adds all these numbers every time, and we have maximum value 7. I want to use again attribute promote to store the maximum of these values. So for example, here I want to use this 7 point something value Yeah, you can see it better here. So want to store these maximum values. Let's write it here, position X, position Z, and change it to maximum, and let's apply it to details. Let's do new names, max pos Z, no, max pos X and max pos Z. So right now in details, we can see that we have these new attributes here and they are equals to our viewport. So, and the final step, almost the final step, we need one more attribute triangle. Let's name it apply new pose. Let's create vector r equals detail, and we take right now radius attribute from our detail tab. Add, and right now we add to position z our pos z attribute divided by detail, and let's write our max pos z that we just promoted. Now we changed position for each point in direction z, but now it's only from 0 to 1. So let's change it the right way. For that, we need to change a bit of our attribute triangle. Let's write 2 multiply by r and multiply by the rest of our expression. And it worked. Great. Let's copy this line and let's paste it again so we can change it for x value. Oh, I forgot to write here radius z. Yeah, because radius we have vector attribute, not float, so we need to exchange it to z and x. Let's write it for position x everywhere, and right now we have everything. It works, but everything is placed in positive coordinates like offsetted, and to bring it back I use center node. Let's compare it with previous geometry. It has the same size. Great. Let's create a null so we can write output and hit the play and it moves. Great. Let's check it with color here and not only wireframes. So I can change now the size of grid, like for example make it bigger, add more rows, and I can also play with some color. Like for example also I can make it bigger or offset it a bit differently maybe. Yeah. So let's change it a bit. Oh no. Let's make it 10 and yeah, it's still moving. That works great. Yeah, it's a bit slower, but still works. And as a final step, it can also be extruded with different thickness. Let's add measure node. So here we have area attribute on primitives, and we can check how the area attribute looks like. So visualize. Now let's create a poly extrude node. Let's extrude it a bit. Oh no, there is something weird with normals going on. Okay, so we need to change it to point normal. Now it fixed. Great. To extrude it differently, we can change it to individual elements, and let's change the scale to area. Now we have everything extruded differently based on the size of the cell. Don't forget to output back. So this is how it looks, but I want to add a little bit more differentiation between them. So let's change it back to Z-scale. Let's copy it and add again attribute wrangle, but only for primitives. Let's write here Z-scale equals area. And right now we should have the same result that we had before. For green and red thickness, I will add attribute amp amp x. Let's see how it looks. Yeah, right now we added also red extrusion and add amp z. So this is how that looks like. I think it moves super nice and I really like how it behaves. So
And there we have it. I hope this breakdown gave you some insights and some inspiration for your own projects. Houdini is all about exploring, so the more you play with it, the more exciting things you will discover. If you have any questions or you want to share your own results, let me know in the comments. I would love to see what you create. Thank you for being here today, and I'll see you in the next one. Bye!